So you paste a question about your own 200-page report into a model, and here's the thing. That model has never seen a single page of it. And back comes this clean, confident, textbook answer about greenhouse gases. And it reads well, and it sounds right, and it has nothing to do with your report. So it's answering from memory, and the whole fix is to make it read your documents first, which is what the rest of this is about. Here's the way to see it. Picture a student in a closed book exam, nothing on the desk to look up, everything coming from memory. And they hit a question they only half remember, so they write something plausible and hope that it lands, which is a feeling you probably recognize. That's your model right now, and it's doing it with total confidence, because a guess and a real answer come out sounding exactly the same. Now hand that same student the textbook, let them look the section up before they write, and the answer changes completely. That's the open book. Now that comparison isn't perfect, because the student decides which section to open, and your model doesn't get to decide. Something has to hand it the right page. And that is genuinely all RAG is. Retrieval-Augmented Generation is a mouthful, but the idea underneath it is one extra step. Before the model answers you, it searches your documents, pulls out the passages that actually relate to your question, and reads those as part of the prompt. So the model stops answering from memory, and it starts answering from the page that's now sitting in front of it. And the two obvious moves are the expensive ones, because you didn't retrain the model, and you didn't paste 200 pages into the prompt. You stored your documents somewhere searchable, you pulled back only the relevant pieces, and you handed those pieces over as context, and that's the whole move. So the model could always read. What it never had was anything in front of it to read, and the open book is the entire technique. So how does a computer search a document by meaning? Which is the part that genuinely sounds like magic the first time you see it. It happens in two phases, and the first one runs once, before anybody has asked anything. So think of it as everything you do before the doors open. You start by pulling the raw text out of your documents and tidying it up, because if your extraction mangles the text, everything downstream inherits that mess. Then you split it, because 200 pages is far too big to search as one block, and the answer you want is one paragraph somewhere inside it. So you cut it into chunks, roughly a paragraph each, and here's where the first real decision shows up, because you don't cut cleanly. Think about what happens if you do. The thought you need starts at the bottom of one chunk and finishes at the top of the next one. So neither piece holds the whole idea, and neither one looks like a match for your question, and the answer falls into the crack between them, which is why you overlap them instead, so every chunk carries the last few lines of the one before it and the first few of the one after. Okay, so you've got overlapping chunks. But a chunk is still text, and a computer can't search text by meaning, so what has to happen to it first? Each chunk gets turned into an embedding, which is a long list of numbers, and that list of numbers is what people call a vector. And the numbers are arranged so that two chunks about similar things land near each other, and two chunks about unrelated things land far apart. The picture to hold on to is coordinates, because an embedding gives every passage a position on a map, and that map is what people call meaning space. So a chunk about greenhouse gas emissions and one about carbon dioxide in the atmosphere sit close together on that map, even though they barely share a word. But you've now got a position for every passage in the collection, maybe millions of them. So how do you find the nearest ones quickly? That's what a vector store is for, and it does one job, finding the nearest neighbors to any position you hand it, without checking every point. Think of a library where the books are shelved by subject instead of alphabetically, so once you're standing in the right section, everything within reach is already relevant. And if that felt like a lot, that's normal. It is a lot the first time, and it gets concrete the moment you watch a real question go through. That's the preparation phase, done once. Now every time somebody asks, their question goes through the same transformation, because a position only means anything on the same map. Then, the store finds the chunks sitting closest to your question in meaning space, and you take the top few of those. And then the last step is almost anticlimactic, because those chunks get handed to the model along with your question, and it reads them and writes the answer. The only thing that changed is that it has the relevant paragraphs in front of it, instead of nothing but its own training memory. So ask it what Chapter 2 says causes climate change now, and it pulls back the passage about greenhouse gases and answers from the open book in front of it. The one dial worth your time is chunk size, and there's no correct setting. Cut too small, and a chunk is one sentence with no context, telling the model almost nothing. Cut too large, and the sentence you need is buried in pages of unrelated text, and the signal gets diluted by everything sitting next to it. Roughly a paragraph is the common default, and the way you find your own number is by trying a few and looking hard at what comes back. And looking at what comes back is the thing to do before you trust any of this, because a setup can look completely healthy from the outside. Picture a retrieval setup answering climate questions well, until a question comes along whose answer you happen to know sits on one specific page. It gives you something vague, so you look at the chunk it actually pulled, and that chunk ends with the words, "The main driver of warming is," and the very next chunk, the one it never retrieved, starts with "carbon dioxide from fossil fuels." The sentence was cut straight down the middle. So the answer was in there the whole time, sitting in two halves, and neither half looked like a match. The chunk boundary did that. So where does this break down? Because it does. Simple RAG is strong on focused, factual questions. The kind-ready answer sits in one place. But ask it to compare the economic impact of climate change across every sector in the report, and it does a lot worse. Because that answer is scattered across a dozen sections, and you're pulling back 3 chunks. And that gap is where better chunking, re-ranking, and query rewriting start. But here's what was going on at the start. Your model handed you a confident, useless answer about your own report because it never opened your report. So it all comes down to the open book. You cut your documents into overlapping chunks so no thought gets split. And you place every chunk in meaning space so you can search by what things mean. And then you pull back the closest few and let the model answer from those rather than from whatever it happens to remember. So before you reach for anything fancier, go and read the chunks your system is pulling back. It's dull work, and it'll save you a week. And I'd like to know what you find. So tell me in the comments the strangest thing your retriever has ever pulled back. I read them. The working code for this one is in the RAG Techniques repository, linked below, along with the notebook that it comes from. And I make these to take the new, complicated corners of AI and explain them until they actually click. So if that's what you're after, subscribe.